Hello everyone, this is the first lesson recording for IM2, May 3rd, 2021. Goal for the day. We are going to continue discovering properties related to inscribed angles. So let's begin by reviewing what we have learned so far. So, inscribed angle, intercepted arc. So if you have inscribed angle, what is the arc here? Arc is just a portion of the circumference, so arc DC is what we have. And the inscribed angle from the arc DC, the central angle that corresponds to arc DC is this red angle. And the arc DC has the measure the same as its corresponding central angle. So this arc measure and the central angle, they're always going to be the same. What else do we know? We know that there are infinite inscribed angles that intercepts the arc DC. We have arc DC here, and there are infinite inscribed angles. So that's one, this is another inscribed angle. Okay, so there are infinite numbers of inscribed angle, and we just need the inscribed angle to be anywhere on the circle itself, on the other side of the circle. All the inscribed angles for the same arc have the same measure, and that's what we discovered last lesson. Now we're going to be looking at the relationship between the inscribed angles and the central angle. Okay, so we've discovered that the two blue angles are always going to be the same in measure when the inscribed angles are intercepted by the same common arc. Okay, is there a relationship between the pink central angle to the inscribed angle given the same arc DC? To do that, you're going to be exploring card number 1 to 6. Here we go. Card number 1, jot down what we learned about different inscribed angles for the same arc. We have arc AB here. Okay, and we can change the arc measure or arc length. Okay, but what do we notice about inscribed angle given a particular arc length? Okay, so this is going to be 66, 66. What if we change the arc length? It's still going to be 34, 34. What if we look at different positions of the inscribed angle? It's still going to be the same. Okay, so given the same arc, okay, the inscribed angle intercepted by the same arc is going to have the same measure always. Okay, Tuya is trying to discover a relationship between arc's central angle, that's the red angle, and the inscribed angle, that's the blue angle, right? Explore by using AB, point AB around to change the arc length or the arc measure, and also moving C to change the inscribed angle position. Okay, so what do we notice? What do you think the relationship is? Is there a relationship between the red angle and this angle? Visually, what does it look like? Okay. When it gets really big, it also gets bigger. Do you see any particular relationship? Okay, do they look like they are the same in measure? If this is 101 degrees, does this look like 110 degrees? Well, 101 is obtuse angle. Okay, that means greater than 90 degrees. Does it look like this is greater than 90 degrees? No, it's certainly smaller, isn't it? Okay, what do you think is the relationship? Okay, here is the reveal. Okay, so it actually reveals the angle measure of the inscribed angle. 92 degrees, 46 degrees. We're talking about the arc AB. If I change the arc measure to say 140, what is the inscribed angle measure? 70. If I make the arc measure to be 80, what is the inscribed angle measure? 40. And that does not matter where the point of the vertex is. So hopefully you're describing that the relationship between the central angle and the inscribed angle intercepted by the same arc is going to be half of the central angle measure is going to be the inscribed angles measure. Okay, now Rosa wants to explore inscribed angle for a semicircle. Okay, so semicircle meaning we are going through the center, that we are dealing with the diameter and we were splitting the circle into half. So when you do that, we have 180 degrees because the total revolution is 360 degrees. How about by first sketching the inscribed angle for arc AB? So if this is arc AB here in red, okay, so what is the inscribed angle? It would end anywhere on the circle, right? So this is the inscribed angle that is intercepted by arc AB. Okay, and here is the inscribed angle that Rosa sketched. What would be the measure of the inscribed angle? Well, if we know that this this is actually a central angle. It's the angle it makes from the arc, the endpoint of the arc to the center to the other endpoint of the arc to the center. So this is the central angle, and the central angle is 180 degrees. And we also know the arc measure is 180 degrees. We also know that this inscribed angle is going to be half of whatever the central angle is. And half of 180 degrees is 90 degrees. Okay, so 90 degrees is right angle. Does it look like it's a right angle anywhere it goes? Yeah, it does. That's 90 degrees. Here is the inscribed angle measure shown. Move point C around to see different inscribed angle for AB. So as long as we're dealing with a diameter, so a segment going through the center, does not matter where the vertex point is, it's going to be always making 90 degrees. This is going to be an important fact that you're going to need to remember. Okay, so which of the following can Rosa conclude? Semicircles have an arc measure of 180 degrees. Well, if you're talking about semicircle, we do make 180 degrees at the center, which also means the arc measure here is going to be 180 degrees. So that's correct. AB is a diameter. Segment AB, line segment AB is a diameter. Yes, that is true too. Angle C is always 90 degrees. Angle C, this is the blue angle. Okay, is that always going to be 90 degrees no matter where the point C is? Yes, that is also true. Triangle ABC is always right triangle. Well, if we know that this angle is a right angle always, then we know that any triangle that forms the on the hypotenuse as a diameter is always going to be a right angle because you're always going to have a right angle there. And angle A and B are always the same measure. Angle A and angle B of this triangle, are they the same measure? Not necessarily. Looking at this is much bigger than this angle, right? So that depends on where the location of the C is. Here, if you have equilateral triangles, then, or not equilateral, isosceles triangle, then this angle and this angle could be equal to each other. But as soon as it's not right at the center, it's going to be not the same. Okay, not sure about any, so that's going to be my option. Okay, all right then. So now we're going to go back to our slides and take notes on what we have discovered. So inscribed angle fact number 1. All inscribed angles for the same intercepted arc are congruent. So if we have the same intercepted arc of arc AB, then the angle C and angle D, it's going to be congruent. So example is we have arc AB being intercepted by angle D and angle C. So angle C measure and angle D measure, they are going to be congruent because both angles intercept the arc AB. they share the same arc. They are intercepting the same arc. Fact number 2, the intercepted arc has twice the measure of the inscribed angle. So for example, if the measure of arc AB, whatever the measure of arc AB is, that's going to be equal to twice, that's the 2 times the measure of angle ADB. So we're really talking about this angle right there. If this is 25 degrees, what do you expect the arc measure to be? It's going to be arc measure of the AB is going to be 2 times whatever this inscribed angle is. 2 times 25 is going to be 50 degrees. So we know the arc measure of AB is 50 degrees. Okay, so let's use inscribed angle facts to find the value of x and y. Okay, so if we know the central angle to be 56 degrees, what do we know about the arc measure here? Well, we have the central angle for arc x, so central angle and arc have the same measure. So if this is 56 degrees, then we know that arc measure of x is going to be 56 degrees. So x is 56 degrees. Then for y, analyze, we have inscribed angle y for arc x. So arc x is 56 degrees. And we know the inscribed angle is always half the arc measure. So 2y is going to be same as x, which is 56 degrees, right? So we know that y is 28 degrees. We can also just go from the central angle. If central angle is 56 degrees, and then inscribed angle is going to be half of 56, that's 28 degrees. Third fact, if the diameter is a side of a triangle with 3 vertices on the circle, okay, so if you have a diameter, okay, we're dealing with half of a circle here, then the triangle must be a right triangle, because given UV is a diameter, then measure of UV, that's the arc measure of UV here. Actually, this side is UV is 180 degrees, okay? And if this is 180 degrees, then angle UTV, this angle right here is half of the arc measure right here, and half of 180 degrees is 90 degrees, no matter where the point T is on the circle, okay? So that means if angle UTV is a 90 degrees, no matter where the point T is on the circle, then we know that it is always going to be right triangle. All right, so then you can use the inscribed angle facts to find the value of x. If I know that this line segment AB is going through the center, okay, now we're dealing with a triangle that is formed in the semicircle. Okay, so we know that this is 180 degrees because this is 180 degrees, so this has to be, and we use the fact that triangle with a diameter as a side must be a right triangle, and therefore measure of angle ACB is 90 degrees because that's half of 180 degrees. That's a straight angle. So 2x is 90, so therefore x is 45 degrees. Okay, what about find the value of x and y? Well, to analyze angle P and angle S. Angle P and angle S share the same arc, QR. Okay, so that's QR is the arc that angle P and angle S share. That means they are congruent as well. So if this is 45 degrees, angle X has to be 45 degrees. Okay, now what about the angle Y? Well, we know that arc PS is being shared by inscribed angle Y and this angle right here. Okay, or angle Q and angle R. So they have to be congruent, and so Y is equal to 40 degrees. Okay, now you're going to be exploring card number 7 to 13.